Everyone, and welcome to the podcast. I'm Brian Beeler, and today we're going to get you guys all caught up on the crypto that's taking the world by storm. It's a mixed bag. A lot of people love it because it's approachable and easy to set up on gear you might have sitting around your house or lab or whatever. On the other hand, it's causing some pain for those that need those high-capacity storage drives for what they would define as actual production work or useful work. But we're going to get through all of that. I've got a special guest, Jonmichael Hands, with me today. Jonmichael, introduce yourself and give us a little bit of backstory on how you got into this Chia coin.
Yeah, so Brian caught me on an interesting day. Yesterday was actually my last day at Intel after a 10-year career being a product manager for our data center NVMe SSDs. So I actually managed all of our NVMe SSDs at Intel from 2014 till today, and did a lot of strategic planning and product management. And I was also the co-chair of the NVMe Express marketing work group and the SNIA SSD special interest group. So I've been working with storage for my whole career. I started Sun Microsystems designing JBODs, right out of college. And the Chia has been very interesting. So I've always been interested in Bitcoin and Ethereum, and I kind of got in, unfortunately, right when, at the end of 2017, when it was right before that big crash, and 2018 and 2019 were pretty dark years for crypto fans. And I've been following this cryptocurrency Chia because I saw that Bram Cohen was involved. I obviously was familiar with BitTorrent all the way back from college, and I was like, this is seems like it's gonna be really interesting. So last summer, it was last June or July, I actually went into the Keybase and downloaded the alpha and started playing around with it, and it was just I have a storage background, and I was just trying to figure out what this does to the disks, and I was absolutely just blown away. So this new cryptocurrency Chia, you have this thing called plotting, which is writing the cryptographic data to the disk, and then you have this thing called farming, which is basically how you secure the network. And I think Brian will probably go geek out on a lot of this stuff, but in that time frame, the plotting actually was about 6 times harder than it is today, and it was writing about 6 to 7 terabytes of data per 100 gigabyte file to the SSD.
Brutal.
And I let the team know, I was like, you guys can't release this software. It's just going to incinerate consumer SSDs. And I basically got in with the team, and over the last 10 months have helped them, writing a bunch of wikis, helping the team understand how SSDs work, understanding plotting and farming hardware, which is just server equipment. So this is a nice, interesting kind of Venn diagram of all my interests randomly coming together. I happen to be a storage expert. I like consumer gaming hardware. I like cryptocurrency. It just kind of fell into my lap. So
well, okay, so there's so much there. You'd have to be a little crazy to leave a corporate gig at Intel to go do this. You have friends, I assume, or family members that must think you're insane.
Yeah, this one to kind of explain. It's hard to explain to family members about what do you do? Some cryptocurrency? Do they have health insurance? Or what? It's that just asking. A lot of people are just wondering what the hell am I doing? And
that's what I thought.
Yeah. So Chia, no, and so we have it, and I think Brian will get into. I have been obviously involved with Chia-related startups, and I might have my own large farm, which is just another way of saying I have lots of hard drives in a data center somewhere. And then, we have a Chia media company that my friend and I run. We actually started it kind of let's just start this silly website and see how it does. And the Chia interest absolutely blew up, and it was clear that people wanted actually that deeper dive on storage, for how Chia works. So we
I think that's a good point, though, is that thing blew up. So, we started messing around with some of this stuff just at the beginning of last week and quickly iterated a couple guides. We did this microserver. We're talking about how to use those nanos for farming for people that want to do this either with stuff they've got sitting around or with a modest investment to go play around with it and see if it's fun. Because I think part of the allure to this particular effort as a proof of space coin is the luck involved, and that you will have better chances of winning these coins if you have petabytes of storage. I mean, the math just bears that out. But on the other hand, you could have one single plot and still win. I mean, that's kind of neat.
It's reminiscent of the early Bitcoin days, and I think this is bringing back a lot of, for people that are have been in the crypto space for a while. It's oh man, you just very easy access and a barrier of entry. The only thing you need to get started is basically any piece of computing hardware and a hard drive. And a lot of people have a gaming desktop sitting at home, and they can just buy a hard drive, plop it in, and then start plotting away. And if a lot of people have done this even just for a few months and then won a couple Chia, and the Chia happened as of today be worth a couple $100, and in the future could be worth more. And so this is funny. Now people are kind of learning about variance and sample size and luck, and okay, how do we get distributions? Now, this is the same way it works in Bitcoin and Ethereum and other proof of work coins. It basically, the rewards are random based on your contribution to the network. In Bitcoin, this is called hashing power, and your chances of winning are proportional to the hashing power you deliver to the network. And if you actually mine a block in Bitcoin, it is actually a random event. Now, people smooth out these rewards with something called pools, and pooling is just a bunch of people pooling together into one team, and then the team wins the rewards, and then the team distributes those rewards out to the people. Sure. So this will happen in Chia, but the idea was that there's a lot more reward frequency than there is in Bitcoin. There is I think 32 rewards every 10 minutes versus in Bitcoin it's one reward every 10 minutes. And today the reward happens to be for each one of those block wins 2 Chia. And again, it's pretty exciting. Chia is worth a couple $100, right? And so the idea is that with the whole thesis behind this proof of space and time being very energy efficient way compared to proof of work is that once you put the data on there, hard drives are very low power, and the hard drive can just sit there, and a challenge comes in on the network, and the hard drive can do some random reads on the actual disk and say, okay, do I have a plot file that has a proof or a result that proves that I have a winning block for that challenge? And if you do, you send that back to the network and you get a reward. And the idea is that if you have more chances to win every day, then that makes it nicer for smaller farmers that just have a couple hard drives. They might have a couple chances to win, a couple Chia every month or every couple weeks. And that's a lot more exciting than Bitcoin, where, to buy a Bitcoin miner, you have to have this, giant, ant miner that has these ASICs, and it's 1800 watts, and it's, super high power, and they're totally custom hardware. The cool thing about Chia hardware is it's just computer hardware. If you have a gaming desktop, or if you bought a gaming desktop for Chia and you bought some hard drives for Chia, and in a year from now you're I want to use it for something else, those are perfectly good hard drives. They work for 5 years. So I think that's also the interesting thing about Chia, is that it's not like it's going to be hardware that is somehow wasted when it's done, or if people want to. And that was kind of the idea, right? I think Bram thought that there may be this over-provisioned space, he calls it, which is basically just underutilized storage hardware out there in the world. So people that are buying a laptop that has 1 terabyte SSD in it, maybe they're only using 200 gigabytes on average.
Oh yeah.
That means on average they have 800 gigabytes of wasted space. Or if somebody buys a 5 terabyte hard drive and they're only using half of it, they say, oh, I can plot to my other half of that and maybe make some money. And if I need that space, I can free it up later. And so that was kind of the hypothesis around this coin being, more energy conscious than Bitcoin, in a way that there's already a lot of capacity and stored hardware out there.
Okay, well, let's talk through some of the fundamentals, because there's more than two, but two core things: the plotting and the farming. So the plotting. Oh, you're a Topo Chico guy?
Oh, it's a nice choice of water, my friend. Yes.
Yeah, I've got the lime.
It's the
I'm
good
a
stuff.
little fancier.
The lime is good. Yeah.
I think they got a grapefruit one too that Whole Foods had once. That's
my wife's got them completely stocked in the fridge.
Ah, that's fantastic.
That's great.
Yeah, Topo Chico was one of my big wins that someone from Dell introduced me. Lon Leviton, the PR guy, one of the PR guys at Dell.
They're everywhere in Texas. Yeah.
Yeah, and he's like, try some fizzy water, and now I'm hooked. And when I found out they had lime, I was through the moon. This is fine by itself, but with a little bit of Tito's and some ice cubes.
Ooh, there you go.
Exquisite.
Now we're talking, Brian.
Okay, so we're going to plot these things. And you talked about the early versions, how write intensive that activity was. And now when you plot, you're using your CPU and your RAM to create this plot that ends up being a little more than 100 gig. Its writes, though, are 250, something like that. So it still needs a little...
Yeah, maybe explain the plotting process. So to create the data, you want to be able to have a compact plot file, which is the cryptographic data that you can very quickly verify. You want to be able to do just a very few amount of reads to basically verify if you have a winning proof. And to do that, they basically write out, today it's about 256 gigabytes worth of temporary data. And then what the plotting process does is actually goes through and sorts that and then it compresses that data into a temp file. And then that temporary file finally gets copied to the destination drive, and that's the plotting process. This is very computationally intensive, so it's CPU heavy, it's DRAM heavy, and it's SSD write heavy. And this was one of the things that I brought for storage geeks like Brian and myself. Like, this is not a friendly application for consumer SSDs. So consumer SSDs have these write caches and the SLC caching modes that are dynamic, that basically have a NAND die that can turn from an SLC die to a TLC die on the fly. And then once a certain percentage of that drive is exhausted, and then it has to flush that cache and write the data that was in fast SLC to TLC. This is not, very fun for sustained workloads because your performance drops. The other thing about consumer SSDs is they happen to be small capacity. They're typically 500 gigabytes or 1 terabyte. You don't have very many NAND die. And the way that SSDs become faster is you have lots of parallelism between an SSD controller and a bunch of NAND die. And so data center SSDs basically use higher quality NAND. They have higher TBW, which is the rated endurance of the drive, and they have higher sustained write bandwidth. So I think I was helping the community right away figure out that, like, the ideal drive for Chia plotting already exists. It's something we call a data center or enterprise SSD. And I'm very familiar with it because we invent them, and I'm the product manager for our drive. So it's been really awesome to see, one, like, consumers actually interested in data center hardware again. If you go back to the Z270 days, like Sandy Bridge and Sandy Bridge E. Oh man, I can't. It's very hard for me to remember those code names. When we launched the Intel 750 in 2014, I think late 2014, early 2015, we launched the first NVMe U.2 drive, and we basically said we worked with some motherboard vendors to put a U.2 connector on the motherboard. At the same time, SATA had revved to SATA 3.2 and included this thing called SATA Express, which they thought would be, a successor to SATA, which would be 2 lanes of PCI Express. And motherboard vendors at the time, we were telling them, no, don't do by 2 drives, just use by 4 PCI Express. It's going to be twice as fast. And M.2 really wasn't, it really didn't exist yet. It was just getting started. And we had these motherboard vendors actually put a U.2 connector on the motherboard. And then, basically none of the other SSD vendors came along for the ride, like Samsung or WD. Or nobody else made U.2 consumer drives, and Intel was the only one. And we wanted to do this because we had the Optane drive, and we wanted to get U.2 on motherboards. So here we are, like 6 years later, and people are buying these U.2 adapters and M.2 to U.2 converters and all this hilarious stuff to get a high performance NVMe drive on a desktop. And it was like, I've been trying to do this for 6 years, and the industry basically ignored me and just said, this is stupid, nobody wants it, M.2 is the best thing in the world. And
definitely some, like creative pros wanted it. Anyone that's using some really intensive applications, because Sonnet makes a nice add-in card that's Mac friendly that holds 2 U.2s. There's a number of others that make these things, and it's funny because we've even gotten SSDs in for review where the vendor has sent a PCIe card with it because they're assuming, I don't know, that they're sending it to not a data center site, maybe a consumer rig, because the prevalence of those ports, unless you have SSD or servers, is less. But yeah, I mean, I guess if you were to rank the best possible plotting SSD, it would have to start with the P5800X and go down from there, or is
absolutely. And so unfortunately, by the way, the P1500X is amazing, and it's the highest performing NVMe drive on the planet. But unfortunately, it's more expensive than other flash drives, and it's not as big. It goes up to 1.5
I think they're like $3,500 in retail or something like that for a.
So ideally, the way that the plotting process works is one plotting process is maybe 100 to 200 megabytes a second of bandwidth, and then that one plotting process consumes about 256 gigabytes of temporary storage space as of today, right? The plotting algorithm kind of changes from day to day, but so the ideal way is you basically do the math and say, okay, for a drive that's 3.84 terabytes, you divide that by 256. I think you get around 14 or 15 basically plotting processes, depending on how long you space between them, which is called staggering. And then you basically want to maximize the utilization of the drive. And then by running multiple processes in parallel, you increase the bandwidth of that drive. It basically increases the effective QDEP by giving the SSD a higher workload.
Yeah, and it's accretive.
This is another thing that I'm just been like so grateful. People are finally understanding how bad SATA is. they're like, oh my God, this SATA drive is bottlenecked.
Hey, don't you trash talk SATA.
Yeah.
I got SATA running in this little guy. And before you, it's, we're running these, what are these, SA 210s, the WD drive. Now, I know that you don't want SATA in these, but there's 2 in here right now, and they're not doing a lot, but this guy's up to 50-ish plots over 4 or 5 days. So it's not fast, but it is doing
what I tell people about SATA is there's been some people that have had very good success with SATA doing a raid of lots of smaller capacity devices. So buying these, 480 gig drives, or people bought these old used Intel 400 gigabyte drives, and then they raided like 8 of them together, and they're seeing great performance. But for SATA, typically you get bottlenecked after about 2 or 3 plots in parallel, where the drive starts really slowing down, right? Because a SATA drive is bottlenecked at 550 megabytes per second.
Yeah, I think we got 3 on these. So
a 2 terabyte or a 4 terabyte SATA drive is just a huge waste because you're so bottlenecked on bandwidth.
Yeah. Now, so a storage guy, one of the first things you would maybe think about would be like, oh, well, perfect. I've got these 2 terabyte drives. I know I can only do 3 at a time. I'll just OP this thing down to 960 gig or whatever, and I'll have all this extra space and endurance and maybe a little more performance. What's the story when you think about over provisioning the SSDs?
Yeah, this is a little tricky. So the way that the plotting process works is, there's probably a slightly better way to do the C++ code, and I'm sure somebody in the future will implement it. But today it basically writes these writes this cryptographic data, and then when it sorts it, it breaks this data up into buckets, and each bucket is basically a temporary file that's 7 to 14 megabytes or something like that, depending on the size. And so basically it dumps all those from DRAM to the disk, and then when that is done, when those temporary files are done and they have to dump it back to DRAM, they have to delete those temporary files. So when that happens, the SSD gets a trim command. Now, a lot of people are understanding that older SSDs do not handle multiple gigabytes of data being trimmed at the same time very well. Now, new SSDs handle that very well. And even in some of the newer Linux kernels, they have something called asynchronous discard, which can kind of help improve the trim speed. But on some of these drives that are 10 years old, that just slows down the performance quite a bit. So the only way over provisioning would work is basically the way over provisioning works is you reduce the write amplification factor, which is basically the overhead of how many NAND writes you're doing to host writes. And it basically tells you how efficient your garbage collection is in the actual SSD firmware. And so if you have a higher amount of over provisioning, you have a lower amount of write amp factor. And if you have a write amp factor that's between 1 and 1.5, then you really don't need trim, because the only thing that trim does is it makes the WAF lower, and it basically helps you get better endurance, better performance out of the SSD over time, because trim is basically just a way of telling the SSD, we don't need these blocks anymore. You can go garbage collect them in the background. Yeah, and that happens very, very frequently in this plotting process. And so people are finding on consumer drives, if they don't have trim enabled, the plot times are 50,000 seconds. You enable a mount with discard, which enables trim in Linux, and now the plot times go to 20 to 30,000 seconds. So it's the huge. It makes sense, right? Because without that, the SSD has no idea what files are being used. All the SSD knows how to do is talk, LBAs, reads and writes in blocks. And it has no idea what a file system is. It has no idea what files are. So you need trim to keep the drive running healthy and good. So I actually don't recommend over provisioning, because most of these drives handle trim pretty well. And if your drive handles trim very well, then it's not really needed. The WAF
doesn't really help you.
It stays around 1 to 1.5. So.
Okay, so if the Enterprise Optane's the best and SATA's at your low end, you really, and we've been telling the same stories, you really want to find something with endurance, because if you plan on plotting for a while, the endurance may be that and the sequential write, or kind of the 2 variables to be keeping an eye on, right?
Yeah, absolutely. And typically, data center drives and consumer drives are rated with a TBW, or total terabytes written. That's the total amount of writes you can write to the drive before the drive wears out. Now, that TBW is often in the data center space. This is coming off a spec we call the JetX spec. It's basically the measuring stick of how enterprise customers basically measure the endurance of an SSD, and they have a very specific enterprise workload. This is typically the worst case when the drive is full and the drive's basically doing its worst case garbage collection. And the WAF tends to be, on a 1 drive write per day class drive, the WAF ends up being about 5. So if you're running a Chia workload and you see a TBW of 1,000, say 1,000 TBW, In Chia, it may actually look, your actual endurance may be like 2 to 3 times higher than that because your WAF is going to be lower in practice. So, but it is a good way to compare drive A versus drive B. If drive B has a higher TBW, it has higher endurance, and you really want high endurance drives for this plotting workload. So.
Right. So you've got the cost. So what can you afford? That's thing one. Then you've got the endurance, which is all measured the same way with TBW, and recognizing that that's sort of a minimum spec that is expected probably within the warranty period, right? So you'll probably get much more.
Yeah, and then with the interfaces, I say with SATA, keep them small, like 480 and 960 gigabytes. If you're going SAS, maybe you can double that to up to 2 terabytes. And then with NVMe, you can use 4 and 8 terabyte drives because they actually scale the performance very, very well. 4 terabytes is probably the sweet spot for NVMe because you also have to physically connect these drives to a system, and hooking up like 10 NVMe drives in a consumer system is just a nightmare. It's an absolute mess. So, typically I recommend just like get a 4 terabyte drive, for an NVMe, hook it up to a desktop, and you're on your way.
Yeah, depending on how creative you want to get, there's actually, if you've got a system, then use it. That's great. But we found that a lot of cities have these upcycling places where businesses will donate off lease stuff and then they'll sell them, and you can actually find some servers that may not be NVMe ready but have a good enough PCIe backplane to slot some things in or whatever. So this is a great opportunity just from a more global standpoint. It's funny because I'm actually taking this Nano home tonight. My 11-year-old's like, follows what I'm into, and he's like, oh, well, I want to do Chia. I'm like, great, I'll set you up with a little thing. You can have a monitor and set it on your desk, and you can just watch the little thing go and plot and do its thing. And learn. We put Ubuntu on it, so learn a little bit of Linux, learn a little bit. I mean, this is a fantastic time to get kids involved, maybe not in crypto per se, but in something that they can see and interact with a little bit more than maybe other tech products.
It's funny you mentioned that, Brian. Cameron, you and I both know, I have a mutual friend. He asked me, he's like, hey, is this too late to get into it? My son was asking me about it. I'm like, you should, because one, it's like a fun activity for you and your son to go build a system, put all this stuff on there. And it's a great, for anything, I put up these like silly little YouTube videos, one of me building a NUC, which my wife was hilarious. My wife was like, what are you doing? Like an unboxing video? What are you doing? I'm like, no.
No, tell her you're starting a beauty YouTube in your
I know. I'm like, job. No. I'm teaching. I'm teaching these people how to fly. It was like a terrible YouTube video. Like I was like, I edited it in like 1 minute between meetings at Intel. But people were really excited. Like they wanted to learn. I could tell they wanted to learn more. So we kept trying to put out a little bit more content. But I think that's been the most rewarding thing about this whole thing is I've helped a ton of people, and especially in the beginning, that have now made a bunch of Chia and are very grateful because that's maybe life-changing money for a lot of people, to farm 20 or 30
no doubt,
Chia. And but the most fun part about it is that a lot of people went way past their comfort zone. The guide that I wrote on my website was like, based on Ubuntu server, and a lot of people have never SSH'd into a system. They've never run a command line. They've never run NVMe CLI. They've never run HTOP, or all these tools that are so easy.
Because all these millennials didn't grow up with DOS. I mean, Christmas. But yeah, no, I think it's fantastic for that. So we're going to explore that probably tonight because he's pretty excited. And he knows, he's like, I think maybe everyone that's getting into this should take the advice of an 11-year-old. Like, he's in it for the fun and the kind of the excitement of the scratch-off lotto ticket. And if he hits, he hits. And if he doesn't, which he probably won't, then he's not going to be terribly upset about it either. But he'll have learned something along the way. And, just getting some experience is with tech. Anyway, that's why I go back to those. Like here, we've got the computer cooperative, but in a bunch of other cities, if you just look locally, like where can I donate used equipment, they'll pop up, and then go check them out. And for a couple bucks, you can go buy a server and go mess around with it and learn. So this is a great opportunity. That's also
a good point, Brian. I think a lot of people are like, don't go rush out and spend like hundreds of thousands of dollars or tens of thousands of dollars if it's way past your comfort zone. Just buy something that you can afford, especially used hardware, and then treat it as a learning experience. And I do believe in the project, and we can talk a lot more about that, but I think it's mostly fun for guys like Brian and I, like, who, talk about storage all day, to basically say it quickly turns into a benchmark, which is like, okay, this system has this much output, and a lot of people are like trying to reproduce that, and they say, well, I want to reproduce that because I bought your same hardware. I've gotten tons of questions. I got tons of questions like, hey, I bought that same desktop and I'm only getting half the output. I'm like, well, did you buy the same desktop? What SSD did you use? And they're like, well, I just bought this other one because I thought it was good. And then it's like,
oh my gosh, the number of posts I see that are like, Samsung SSDs suck for plotting. I'm like, whoa, which SSD? And it'll be like the QLC one. I'm like, oh, brother. Yeah, don't do that. Well, so talk about that for a minute, because we're on 1.14 is the current build of the app, and it looks like you guys are iterating relatively quickly every couple weeks. What's going on there? What enhancements are there? Is it mostly stability? From 1.2 to 3 really dropped that temp space a lot. What else is happening there?
Yeah, there hasn't been a ton of focus on the plotter. There's probably still some algorithmic benefit. So part of the hard part of that plotting algorithm is not, there's probably lots of enhancements that can be device specific still implemented in the code that are like, oh, this one's better for SSD. Right now the code is kind of general purpose. Like, it works on SSDs, it kind of works on hard drives, it's just slower. There will be a point where they can actually improve the IOPS usage of the drives and actually make it better. But the team's working on a lot of those other challenges, like I mentioned, with like pooling and some of the other near-term priorities. So the plotting, as we've seen, there's been, I think as of today, like 2.5 exabytes of data plotted on Chia with the plotting code that they have. So, they believe that it's sufficient enough right now, and they've made a lot of enhancements, at least in the short term, to kind of improve at least the memory and DRAM and temporary space utilization, because that's a big expensive part. It's a very expensive part of the plotting hardware is like DRAM and SSD. So if you can reduce that, which they did by like 50%, that's huge.
So you reminded me, we've gotten this question a couple times. We talked about the Optane drive being great for plotting. What about RAM disk and or persistent memory? Can either one of them play here effectively?
Yeah, the interesting thing about higher DRAM is you can do an in-memory sort, which is basically, I just mentioned, like in the plotting algorithm, you write out this 256 gigabytes worth of data and then sort it and compress it and all that stuff. You can do all that in memory if you have enough memory. Now, the problem is that it's so computationally intensive and CPU intensive that it's not all that much faster than doing it on disk. And people realize very quickly that when DRAM is $3 a gigabyte and SSDs are 10 to 15 cents a gigabyte,
okay, there's just not enough improvement per terabyte.
You'd have to get a 10 to 20x improvement on plotting speeds, and you get a 20 or 30% improvement. So the math will never work out where it's cost effective. Can you do it? Yes. Is it fun to try? Yes, I've done it. But is it cost effective? No.
Okay. So most people won't have access to that. So we'll just table that. If you've got a ton of RAM, go mess around with it, knock yourself out. Yeah. All right. So we've made the plots. Those go along. They can be staged so that multiples are running at once on one drive. They can, when one completes, another one can start. You can set all that up, either CLI or in the GUI. But ideally, you'll take these plots as they complete on SSD and have them auto-migrate to something else. Now, you can use an external. We've got a bunch of these SSDs just sitting around because they're in the conference room. But the best case scenario is... capacity guy, this is a 14 terabyte. The hard drives are up to 18 now, commonly available. I mean, maybe not currently, but generally available. And the system can migrate straight from the SSD to the hard drive, where it is now in a new task of farming. So kind of explain the technical challenge there, or the technical function of the farm. And you talked about a little bit already how the match occurs and you win a block, but maybe just a little bit more on the farming and how that fits into the overall coin's sort of vision of stability and such.
Yeah. So farming is the key to proof of space, right? It's a proof of space where you're trying to prove that you are actually storing amount of space in your hard drive, and your chance of winning is proportional to how much space you have divided by how much space is out there on the network. And today that's called net space. And it's very similar to hashing power in Bitcoin, where you have your hashing power and then the hashing power of the network, and you divide your power by the network, and that's your chance to win. So in farming, all that matters is really how much capacity you have. They've architected the algorithm and protocol in such that it doesn't favor different types of storage media type. You just have to have a lookup complete within 30 seconds. And typically on a disk, you have to do 7 sequential reads. And at different places in the disk, sequentially meaning you have to do them in order because they have to hash together to basically see if you have a proof or not. So the workload is very, very friendly, and it's very environmentally friendly. It's a write once, read many workload. So the disk basically stays active and spinning, but it's the amount of I/O that's going to the disk during farming is very, very low. You basically
that's why the hard drive's a better fit for farming.
Absolutely,
because
right.
you got a capacity issue there.
Yeah, well, hard drives are the most cost-effective storage solution. They are the lowest dollar per terabyte, and they are lower than SSD right now. And typically, at some point, right, I believe that in some time in the future that will not be true, but that's for another talk, Brian.
Well, those QLC SSDs with dedupe and compression can get pretty darn close, even at 15 terabyte.
But so for Chia, some of that benefit doesn't come through because it's not a high performance workload. Right. So you don't care about compression or dedupe or data protection or anything, and you just literally store the plots on this hard drive. If the hard drive fails, then you throw it away and get another one and fill it up with new data.
Right. So that's a good point. This system setup is best for independent disks. Just JBOD, keep it simple, no RAID, and that's another RAID. one that's really, really hard for storage guys because I was like. I know. I'm like, oh, great. Well, we'll put it in a RAID 6 or whatever gets protection. Throw it away. You want as many plots as possible.
Got it. Yeah, and that was hard for me too, Brian, because I had to think through that. Like, okay, when is it going to make sense? When plotting was 6 times harder than it was today, it actually there was some scenarios where you're like, man, this might make sense to actually have some data protection. But now that plotting is relatively easy, right? It's easier than it was. The data is treated as ephemeral or fungible, right? New plots are just as good as old plots. So if you lose data, you can recreate them. So you can see this quickly gets into the farming goals, which is store the largest amount of data in the smallest amount of space for the lowest amount of money at the lowest power possible. Yeah. And that is basically the same things that hyperscale data centers are optimizing for. If you're a Facebook or a Microsoft and you're saying, I want to have the lowest total cost of ownership per rack, that means I paid the lowest amount for the hardware and I pay the lowest amount of money to operate that hardware. And
you utilize it as much as you can and still keep those other things under control. Absolutely.
And so we have a calculator that we have, we can share. I wrote a TCO model for SNIA that's open source now that I help people use for Chia, basically saying, okay, well, how much am I going to spend on plotting hardware? How much am I going to spend on farming hardware? How much am I spending total? And then what's my expected returns? And it's fun to kind of work through this math and figure out okay, is it, how much money should I put in? Is this stupid? Is this a good idea? But farming is fun because now, again, so we talked about how plotting is really fun for storage geeks like us because it uses high performance SSDs, it uses NVMe, it uses high endurance storage. It's just like we're having a field day for SSD experts. We're just like, yes, finally, people care about this stuff. But the farming is really fun because now you start stressing the kind of computer hardware as far as density for disk drives. And consumer NASs are actually very good at this. Like a Synology or something is like a large number of drives in a small space, but the cost is very high and the complexity is high. So people are figuring out, okay, you can buy a desktop case and fit 8 drives in there or 12 drives. And then they quickly realize when they want to go beyond 12 drives that oh, that's not going to fit in a desktop. Shoot. So
So what's next?
Yeah.
Well, these trays may look familiar. They're really popular out of an old NetApp JBOD. It was a Zyratex thing. Back in the day, Zyratex made the JBODs for everybody. They all look different, but they were all made by 3 companies that made most of these things for the old storage guys. But that's another type of thing that you can find used or even on eBay.
The funny thing is that now that the Chia's become pretty popular, they're much more expensive than they were 6 months ago. People were selling used JBODs for $200 or $100 because it was what are we going to do with this thing?
Oh, it used to be garbage, and that's
exactly.
why they end up
Yeah.
at these upcycling places. But
So,
now they're in demand. So let me ask you a question though. So when the challenge goes out, it's looking for a match, right? A plot match. Does a plot match have to exist? Like how?
Yeah.
Is
So
that?
so
Clear that up. Like
so each plot is created with a unique plot key, and then it's created with a pool public key and a pool farmer key, and then those three hash together to make the plot ID and the cryptographic data that goes into the plot file. And a challenge comes in on the network, and you're basically just checking. The first thing that happens is there's something called a plot filter, which basically filters out basically there's a 1 in 512 chance that a drive passes the plot filter. And this plot filter happens every few minutes and changes. So this is really efficient because now you don't have to check the actual file. You just have to check the file name, which has a hash of the plot in it. Okay, if you're lucky and you say, okay, you see this in the farming GUI, it says how many plots have passed the filter. Okay,
so when it says like 1 of 10, that means one of your plots has met that initial challenge request.
You got it. And
okay.
It's just a pure math. Every single plot has a 1 in 512 chance every single time there's a new filter. I think it's like I can't remember if it's every 3 minutes or 10 minutes, but for the filter, but I have to look. So if it passes the filter, then you have to basically say, okay, now we know that this plot is kind of hot. Okay, we're ready to look at this plot. So now you have to do basically 7 lookups to say, do I actually have a response to this challenge? And if you do those 7 lookups and you have a response, then you do the full lookup, which is 64 reads, and then you send the network your proof and you sign it with your actual key. The farmer has a private key that it signs that proof with, and you send that out to the network and say, look, I won. I have a response to that challenge. I have a valid proof. And the way that the difficulty works in Chia basically is the difficulty automatically adjusts every day in such that there will be 32 block rewards per sub slot, and that's every 10 minutes. So there's a block every 18.75 seconds, which people can win a reward. And the network kind of automatically adjusts every day. There's a thing called an epoch, which basically adjusts the difficulty, and it basically changes how many people are finding those proofs. And so the way that the network actually estimates the amount of capacity that's on the network or the net space is actually by figuring out how many proofs are coming in. Right? If more people are finding proofs, then that means there's actually more capacity on the network, and the difficulty needs to be harder.
So is it possible for a challenge to not have a proof, and conversely for a challenge to have multiple proofs?
Yeah, this is one where if there's a race condition, these are very rare, right? Like, so the probability of these happening are, now once the difficulty is very high, it's you just really quickly come to the law of big numbers where these things are very improbable. But I think in that very case, I think it's just whoever gets it into the network first, whoever has the lowest latency. But it's now there's something called a reorg, which is a little bit more complicated, and that's probably a topic for some other day, right? Where there's foliage on the blockchain, and then sometimes there's one with a higher number of weight, which means more proof to it, and that one gets to be the winning block, and it actually can reverse transactions on the other ones. But this is just the way public blockchains work, and that's a much more complicated topic, which the guys who actually wrote the blockchain software can help you.
We'll stop there.
Yeah, we're storage guys. So
well, you mentioned NAS. There's a number of people that have gotten kind of creative there that are running either Docker, or if they've got a more powerful Synology or QNAP, the virtualization module in their NASs, and doing a whole like little hyper-converged thing. I mean, people are getting pretty creative with their rigs.
I really so the only problem with consumer NASs is they are defaulted to set up to guide you to using data protection, right? Because if you buy a NAS and you're storing files on there, like, you don't want to lose them. So like the typical software is like, okay, make a RAID 5, back up your data, and so it's kind of hard in some of these NASs. You have to say, well, here, don't do that. You actually want to make a bunch of individual volumes. The other problem with this NAS software is when you are sharing over SMB or NFS, and you have like thousands of plot files, which are 100 gigabyte files. These network file systems do not like that. Like, there is a high latency.
Well, there's an overhead for their software. I mean, they're not ideal, but if you've got one, with a free bay or whatever, it can be done.
Yeah, absolutely. And if you, I know this is again probably another advanced topic for Chia users, but like there's a concept in Chia called a harvester, which is a little bit of compute local to the storage, which can basically just look for proofs. And then if a farmer sends them a challenge, and then on that remote system, instead of sending all that data back to the farmer every time proofs come in, it only sends it back when they find a challenge. And so it actually greatly reduces the network traffic by having these little things called harvesters that are kind of local to the storage.
Right. So that's actually an interesting point. If your main node is your hub, you can have farming nodes that are, I guess you call them, they're harvesters in this terminology, right? And they feed back to your main node. Yeah, the network hit's not that heavy, but talk about, we get a lot of questions too about the public network. So your internet connection, most are pretty good, but we've got some people that are trying to, like with something like this, where maybe they can't get hardwired for whatever reason, that'll put a Wi-Fi card in there. I know that adds a little bit of jankiness to the setup, but what are the network requirements in terms of availability?
Wi-Fi's time. You have plenty of time to respond to a challenge. The only network problems. Remember, this is like think of this like BitTorrent, right? It is a truly decentralized protocol. There's no like master node somewhere that's like controlled by one guy. It's just completely decentralized. You're just talking to other peers on the network that happen to be running the software. It's absolutely completely decentralized. So with that brings lots of problems, right? Because now you have all these weird things about syncing issues with IP addresses, with NAT, with DHCP, with IPv4 versus IPv6. So the way it works is you want to have one farmer that has a IP address, and that if you're on a standard ISP with IPv4, then you actually have to forward that port. In Chia, it's called 8444 is the port that they use, and you have to forward that to your farmer, and so that your farmer can actually open up its doors to other connections, and then that allows you to connect to more peers. But it is a truly decentralized protocol, and lots of different problems can exist. If you try to run lots of multiple nodes in one house under one IP, there can be double NAT issues where they're both trying to get forwarded to the same port, and you might have a time where you can't respond to a challenge in time because it's responding to the other host. IPv6 largely fixes these issues, right? You can have IP address, different IP addresses on the same local network that have the same port. So this is kind of fixed on IPv6, but a lot of people aren't using IPv6 yet. I even have support for my ISP, and it's hard. It's just hard to set up. So there can be lots of weird network issues. So, and these are the hardest ones to debug, but part of why it's fun, right? People, every time somebody's had some challenges with network stuff, you have to remember this is running on its own. Like the Chia team could get wiped off the earth tomorrow, and this protocol and network would keep going and chugging along. Literally. It is a completely decentralized protocol.
I've seen enough movies. California gets blown up all the time. So
yeah, right.
It certainly could happen.
Right. I'm driving to San Francisco in an hour or so. So you gotta, knock that off.
Okay, so decentralized keeps going. I also want to get into the pools concept. That's one that you've talked about on the edges a couple times, where a bunch of small users or big users, I suppose, could pool their assets, win a challenge, get the coins, and then distribute them based on conceivably plots under control or some math, right? So that's something that people are super excited about. There's been a number of efforts to kind of end around that in a creative way, I suppose, but maybe not advisable. What's the official position on pools? Yeah. What's the deal there?
Yeah, the Chia team is going to be inventing their own pooling protocol, and that comes with a slightly new plotting format, which basically includes there's this thing in the plot file called a puzzle hash, and it has to do with something along the lines of the idea with the new pooling protocol is they're making it very easy to basically have your plot files, and if you want to switch pool to a different pool, you can do that with a smart transaction. And the way pools work, I mentioned, is basically you're donating your space to the pool, and then the pool gets all the rewards, and then the pool said, okay, you had 1% of the pool space, so we're going to give you 1% of the total rewards. And then the way that the pools do this is they distribute basically either daily or very frequently. So today, if you're a small chia farmer, you might get a reward once every couple days, once every week, once every 2 weeks. The way pooling works is you get rewards every day, and those rewards might be small, right?
Mm-hmm.
Every single chia coin can be broken up into a trillion mojos. That's what they call it in
Oh,
chia, as a mojo. So
okay.
yes, I did it. Yes, that's I didn't name this, by the way.
Yeah, that happened before your time.
Yes, this is from the Chia team. But so you can basically get sent any number that's smaller than one Chia, right? So you can basically break up a Chia into lots of different little pieces. And then so it's cool. So these people might be, okay, I have a couple hard drives. I'm running my hard drives on my system, and I get like $30 a day or $50 a day or something. That's great. Like, people are just going to be stoked about that. So a lot of people are excited about pools. And unfortunately, the Chia team did not anticipate the network and the excitement for the coin growing this fast, and so they thought they had a lot more time to implement pooling to where, it wouldn't, right? It really doesn't make sense when there's only like an exabyte on the network, because if you're a small farmer with a couple, like tens of terabytes, you can still win every, so often. Now that the network's gone so big,
yeah, you can win, and more importantly, you can match growth without a tremendous expense.
Right.
Now the matching growth is kind of out the window as of this week, pretty much.
Yeah, but in a way that makes it more interesting, in that, like, the longer term, all that's going to matter is how much capacity you have. So now there might not be such a mad dash to get everything plotted tomorrow. I mean, I think people still have that.
Well, the expectation, right, is that we're at 2.5 now, right, that it eventually smooths out somewhere. I mean, it'll keep increasing, but it shouldn't keep doubling every week, right?
No, this is my we've already seen retail tightness in the storage market in the kind of channel space, where the high capacity drives have sold out. There's a 13 to 16 week lead time. Even if you buy 12 or 14 terabyte drives new, there's like 2 to 4 week lead time.
Right.
And so we've exhausted the supply in the channel. You have to think about this. If the global hard drive market is 1.2 zettabytes and the retail space is only 130 exabytes, the fact that Chia's increased demand by like potentially 5 to 10 exabytes in a few months is mind-bogglingly insane. And this is why all these storage vendors are having emergency meetings to go figure out what they're going to do.
Oh my gosh, I can't imagine those meetings, because they must be so happy.
Right, driving demand is good.
You spent your career trying to kill those guys, and now you need them.
Now I like them.
Yeah.
No, to be fair, for Chia, you just need the cheapest thing, which happens to be a hard drive. Again, I am for like actual usable storage where you care about performance. There's no question that, to me, and that QLC and other SSD technologies will overtake hard drives in the future for anything performance TCO. But yeah, this is a fun one. So I think I have a hypothesis, and Brian, you can, I could be wrong here. I think that there's no way that it's going to be more than like 15 to 20 exabytes by the end of this year, because that's like 1 to 1.5% of the entire global hard drive market.
Well,
I mean, that would be insane.
Well, yeah. So there's that issue, and then there's the coin value issue, because that certainly plays into the willingness to make certain investments, right? Few would go stand up a petabyte, of this if the coin doesn't maintain some sort of fundamental level in the math of you winning. I mean, this is kind of neat, because it is just math at the end of the day. And you talked about the calculator before. There's dozens of them out there now, where all you have to do is say, what is it now? What do I have? And then do the math. How does it work? And does it make sense for me to add another 14 terabyte drive or not?
Yeah, and Brian, just to be, the reason why I'm so excited about this project, I'm a huge Bitcoin fan, but Bitcoin consumes 0.5% of the entire world's energy right now. And it's hard for me, being a Bitcoin fan, to be like, okay with that. And Chia is the first cryptocurrency where I really think that they've actually done a first principles approach of like inventing a new cryptocurrency that's completely decentralized. They have a good business model where they're going to kind of merge the old world of the finance world with the new world of crypto. They're actually going to go public as a publicly traded company. So I believe in the company's vision. I believe that in the software and the actual protocol that they've written is brilliant. Every single time I learn something new about the protocol, I'm just like, my mind is just blown. And that's why it's been so exciting over the last 10 months of working on this project. Right. But, so let's see. So Bitcoin today, I think it's taking about 16 gigawatts if you consumed every hard drive in the world for Chia in this year that's going to be manufactured in 2021, I think you're at like 500 megawatts.
Okay.
Orders of magnitude better energy utilization. Today you're probably like 5 to 10,000 better energy utilization as far as Bitcoin. And I've actually written a model on chiapower.org. It's an open source thing where I hope to get this data out to more people, because I am actually, there's going to be a lot of people kind of throwing stones at it. Like, isn't this just like Bitcoin? People are buying a bunch of hardware and it's wasting it. And
Sure.
They don't understand the math. Like, this is more decentralized than Bitcoin at, thousands of times less energy. And like, just running the numbers, this is the only one that I truly believe has the actual potential to do that. So,
well, there's no doubt that the green connection is kind of fundamental to the organization and what you're trying to do here. And yeah, I mean, I was talking to Kevin because he was messing around with some servers the other day. I said, well, what's this going to do to our power bill? Because, I pay that thing.
Yeah.
He doesn't mind spinning up all the servers in the lab.
Once.
but really, it fundamentally, if it's a plotter or if it's a farmer, it doesn't really matter. It's just a server. They really don't take that much. I mean, we spin up 8 servers just to test the storage array, and we'll do that for a couple of weeks, and it doesn't. We don't really feel it. I mean, at a certain level, I guess you'll see. Just like when you buy an EV, you'll see a little hit on your power bill, but it's not huge.
I think people have in their heads that this mining thing is like Bitcoin, where you have one miner that's like 1,800 watts. 1,800 watts is enough to run 180 hard drives and 2 JBODs. That's comparable to one Bitcoin miner. Like, okay, you can have 60 hard drives running for less power than one graphics card, one NVIDIA graphics card today. So like, people just have a hard time comparing like one thing versus the other. Like, when you just look at it objectively and just say, what is the power consumption? This isn't some like crazy mystery. We know how much power hard drives consume. Like, this is not a mystery.
No, yeah.
So yeah, a lot of that's just been educating people on like what the actual power consumption and stuff is. And I mean, to be clear, the network is growing fast, and there's still concern of this. So I think there's going to be a lot more education needed. So I'm glad I got to have a chance to talk about it.
Oh, absolutely. No, I think that's an important point. The coin just started trading. You could kind of trade it before, but it's trading publicly now on Tuesday or Monday, right?
Yeah, there's a couple exchanges. There's one in Korea, and whatever we say here will be outdated in 2 weeks from now, Brian. So I won't.
But you could go buy it today on a lot of different places if you wanted to.
Sure, yeah. I hope very soon in the U.S. I think there's some overseas exchanges that are live, and I mean, it just started transacting. I mean, it's very, very new. The network's only 6 weeks old, so it's not like this has like been around for a long time. So yeah, I hope it's going to be trading in the U.S. on major exchanges soon, because I have lots of friends asking me where to buy.
So what does it take? I don't even know how this works. So what does it take to get into Coinbase? You obviously need some degree of credibility, although with crypto, even that's out the freaking window at this point. If you look at the top 10 traders.
So Coinbase actually said, I think in an article in 2018, that they will be trading Chia at some point. So they've actually publicly stated that they'll have Chia on the exchange. But it's just a matter of like, it's a technical challenge of like, how fast can they do it in a safe way? So
right. And there's got to be some volume and interest at a certain point, right, to justify the effort.
I think the demand is there, at least from just my small circle of people that have. Every friend that I've told about this is like, this sounds amazing. Like, we want.
Your friends are all nerds, so I don't know that. I don't know that counts. Okay, so explain one more concept. I know we're probably getting close to the edge of your time, but. You talked about the mojos. Of course, if you ultimately use this transactionally, someday you may not buy something or transact something that costs one coin. You might be less. So splitting it up makes sense. How do the farms need to be online to validate transfers? How does that work? Can you explain the fee system a little bit? Because I think there's still a lot of confusion about that too.
Yeah, so when a farmer wins a block, you're actually putting real transactions on the network into that block and putting it on the blockchain. And the way that the farmer prioritizes which transfers go first are basically who has the highest transfer fee. Now today the transfer fees on Chia are like basically zero because it's got about 5 to 10 times I think the your transaction bandwidth as like Bitcoin today, and so it'll be probably many years before they have to do off-chain transactions similar to like Lightning and Bitcoin. But yeah, and so the way that farmers work is in the future, if you're a farmer and you're actually validating the chain, you get the block rewards from the actual Chia blockchain, and you may also get additional rewards that are coming from farmer fees from transactions. And today that's a very, very tiny amount. Like I've gotten a couple mojos extra from from fees, but
So just real quick, is the fee? How is the fee tied to the transaction that's tied to the actual coin or the block? I'm just a little fuzzy on it still.
So if I want to send you I think it's every 3 blocks is a transaction block, and so if I want to send you to Chia right now, Brian, I could send it with zero fee, and it will likely get go through in the next block because there's not very much volume in the mempool. The mempool is like how many transactions are outstanding in the network. And so if that volume gets high, when we saw very crazy days and volatility in Bitcoin, the transaction volume got very high and it got very expensive to send. And so it's basically a function of like how many people are also trying to send transactions at the exact same time. And today the network can handle quite a bit of bandwidth. So if I want to send you a coin right now, Brian, it would be very easy. I just send it to you for 0 coins in about 1 minute.
Here, let me give you a wallet address.
Yeah,
let's test your theory live.
Let's test it out. Yeah, and the fee works just like Bitcoin, whereas most people in Bitcoin, like if I'm sending Bitcoin to myself, I typically use a very low fee, and I don't care. It might take in Bitcoin, it might take like 6 hours or something to go through with like a 0 fee or 1 Satoshi fee. In Chia, the transactions happen much quicker. So now
isn't it in the best interest of the coin though to keep those transactions fees as close to 0 as possible?
We want to incentivize the farmers for participating too, but yeah, I mean,
right. Okay.
It's just a supply-demand based market thing, right? So the fees will be very close to 0 as long as there's not more transactions than there is bandwidth. So I don't expect that to happen anytime soon. The only time the mempool was full so far was like the first 5 minutes of transactions were live. I think so.
Yeah, that was fun.
Yeah. I tried.
Yeah, wasn't there some dude? Was it you that put a five coin?
I did. I didn't do that high, but I wanted to get the first block, so I actually submitted a transaction with a very high amount for the first block because just for fun.
That was you. I know that was. I knew that was you. Yeah, that's cool. So leave us just with some thoughts on what's the end game for this, for the token, for the whole blockchain. Like what's the end?
Don't even think about it like token. This is a platform. This is a blockchain platform. They have these things called colored coins, which you can go create that are kind of like you can do NFTs or decentralized exchanges. You could do your own tokens on top of Chia. I mean, what they're claiming is they built a cryptocurrency that's more decentralized than Bitcoin, that has a fundamental backing with the company that can actually get it to scale with U.S. institutions, that has a on-chain programming model that they call Chia Lisp that's actually supposed to be better and more auditable than Ethereum. And if they are successful on their mission, then they will have an Ethereum and Bitcoin killer in a way that's more energy efficient and green that uses storage. So, I mean,
that's strong.
My mind's just blown right now. And obviously that these ecosystems don't happen overnight. Like Ethereum ecosystem has taken many years to mature. And I think that they know the same thing will happen in Chia. They are in it for the long game, and they do not see this as some kind of fad. They do not see it. They don't want people to pump and dump the coin and get excited about the price. They want people to really believe in the ecosystem, believe in the mission that they are trying to do a more green, decentralized cryptocurrency that can actually institute smart money and smart transactions in a way that's auditable and usable by real institutions. So I, for one, am really excited about it.
Well, it's interesting when you think about it like that in terms of viability. I know I told you I'd let you go, but one other thing. We've seen in all the other coins that you've mentioned, splits or fragmentation that happens throughout, whether it's Ethereum 2 or Classic or Lite or Bitcoin Cash, like all these other things. What happens 5 years down the road with Chia? How do you keep how do you plan for either protecting against splits like that or
typically in these things, the largest network with the largest support and ecosystem wins. Chia is completely open source. If you go to chia.net, you'll see the open source software on GitHub. If somebody wants to fork it and make their own coin called Brian Coin, and it uses the Chia protocol, they can do that tomorrow. So
no one's going to mine my coin.
You got it, right? So it's kind of like a supply demand thing. Like, can somebody do it? Yes. Will somebody be successful in doing it? I don't believe so, but that's the kind of fun thing about cryptocurrencies. It's a literal true free market. Like the best thing wins.
Yeah.
Like, and people vote with their hardware.
Well, yeah, that's the thing too, is that for farmers that get this set up and they too antsy to wait for pools and get frustrated, it's stuff that you can reprovision and go throw it in NAS or put true NAS on it, and we're doing a lot of work, especially with this little mini microserver guy. True NAS is pretty fun too, to store all your family stuff if you don't trust public cloud or whatever you want. So yeah, this is not like maybe like GPUs that if you're not gaming or doing something else with them, they have no functional purpose for a lot of people.
Well, Brian, this was a lot of fun. I'm sure if your users are excited about this, your readers, I was one of your readers prior to this call, of course. Brian and I know each other from working through Intel. But if everybody's excited about Chia, I would love to come back and we can chat about a deep dive on optimizing, plotting, and the nitty gritty into the storage hardware. Because I think
now we might get talking, because we've done a lot of sort of lower end how to get into stuff, but we might have to throw some servers on the table and start to get real deep on config.
A lot of the people that are asking me questions are actually a lot of the very technical questions. Like, okay, I've got 3 terabytes a day output. How do I push that to 5? I want to push this system to the limit. How do I do that? So that's been the really fun part for me.
Yeah, and even we've had that challenge while Kevin's been messing around. Is like, well, what happens if you do this, or use AMD Epic Gen 3, or use the new 8380s from Intel? Like, there's so many questions, and it's a little bit fuzzy in there. So, but yeah, I'd love to do that.
Yeah, we'll save that for round 2.
We'll need more time for that.
Yeah.
All right, well, this is awesome. Thanks for checking in. I know you got to drive to San Francisco. This will be great. I think this type of communication and pushing it out there will just help people understand and get the word out on more platforms. So
appreciate it.
We'll see how it goes.
It's been a lot of fun. I'm a little farmer guy now.
Yeah. Well, we've got plots but no coins, but that's a different story. I'm not going to be that guy.
Hey, may the luck gods be with you today, Brian.
Yeah, I'll go refresh again and see what happened. All right, Jonmichael, thank you for joining us
Brian.
on the pod.
Take care. Bye-bye.